This lecture is based on the ion-dipole. As in previous lecture, I've told you about the dipole-dipole moment of attraction. If we talk about the ion-dipole, so basically the word here ion means the charge. As you all know that ion is a molecule that have positive or negative charge. Just suppose that we have NaCl for instance. Now, if we separate Na from Cl, what will happen? The Na will get positive charge and Cl will get negative charge. Now, these are called the ions. If we talk about the dipole, so basically the word here di means two and pole means positive or negative part or charge or side of the molecule. As I told you that the Na is positive and Cl is negative. Now these are two molecules di. This side is positive and this side is negative, just like a magnet, north and south. So these are called the poles, the positive pole and the negative pole. This is called the dipole. To understand ion dipole, the best example can be seawater. Now, just suppose that this is a seawater and you are dissolving salt in it. Now, what will happen? The water will be dissolved in the salt or the salt will be dissolved in the water? Of course, the salt will be dissolved in the water. Now, why this happens? And what are the bondings between the water and the salt? Now we know that the salt, what is its formula? Its formula is NaCl, as I told you in the previous example too. And what is the formula of the water? It is H2O. If we gonna break it, it will be something like H positive plus OH negative. Now, just suppose that here we have two different ions, two different molecules that are going to be dissolved. Now, as you know that the positive terminal attracts the negative one and the negative terminal attracts the positive one. So, that's the reason that the water molecule will be attracted towards the sodium. And now, as you all know, that the positive terminal attract the negative one, so here it will be attracted and here chlorine will be attracted by hydrogen. Now, the question arises, why do NaCl dissolves in the H2O? Why don't H2O dissolve in the NaCl? Now, the answer to this question is very simple. Basically, the electronegativity of the H2O is negligible as compared to the NaCl. And you all know the polysaccharity is the factor of dissolution. So if the polyserability is less, so the dissolution will be less. Here, the sodium chloride has more polyserability, that's why it will be dissolved. But H2O do not have the polyserability, that's why it will not dissolve. If we talk about the definition of ion-dipole, so it will be something like an ion force is an attractive force that results from the electrostatic attraction between an ion and neutral molecule that has dipole. Now, the point was that the ion, just suppose that we have ion Na, it will be attracted towards the dipole H2O. Now, there is a point that the NaCl will be dissolved in the form of the ions, because there will be breakage of the positive and the negative terminal, as water do have more amount of H2O. So that is a point that here the ions, a neutral molecule that has dipole, will be dissolved in ions. Most commonly it is found in solution. Not most commonly, always it is found in solutions, especially important for solutions. Now these ion dipole mostly happens in liquids. That is also a point. So do you understand that the liquid have the attractive force which makes the solvent to be dissolved, called ion dipole. And thanks for understanding this lecture. I hope that you get all the points that I told you.